I am going to show you how to do one of the harder questions today. So this is what we did yesterday from 9.4, but this relates to questions 7. Hang on, let me get my book back out. This relates to questions 7, let's skip pages, 8 and 9. So when we were doing this yesterday, we were looking at how two different things interact with each other. Annoyingly, we now have three. So first of all, let's figure out what on earth they're trying to get us to work out. We want to find the increase of the volume, the rate of increase of the volume. Okay. And it's when the edge is this. So if you think about what we're being asked to find, we want the volume, right? So we want the difference in the volume with respect to what? Well, it's almost always the same answer, but it's about time, right? Because the volume is being affected by time. This is the rate of increase. We know a whole bunch of stuff is going on, but in the end, we really want to find the volume, the rate of the volume, the difference in the volume in respect to the difference in time. All right, so as we talked about yesterday, we talked about doing it like this, where this is dV and this is dt. Now, it's not quite like this because there's actually a third thing involved, which is more annoying. So actually, this is dt, which means before when we had these two things to cancel out, we will, but we're also going to have another thing to cancel out. You'll see that we have surface area, we have time, we have volume, and we have length. So that's really annoying. So I'm going to call the length x because that's the variable on the side, right? So if we've got a cube, what I'm going to say is that the length is x. Okay, so that's how I'm going to use d for time, v for volume, a for surface area, and then I'll just use x for length. So what we want is the volume in respect, so the difference in volume in respect to the length. So then these two things have to match. So then I also need to figure out the difference in length with respect to the area, right? Because the volume is going to, well, we have to start with volume. The volume is impacted by the length, obviously, but the length also impacts the surface area, right? The thing on the top is doing the impacting. So this is associated with this, and then the area is then being impacted by the time, right? So we need the relationship of these three things going on. So first of all, let's start with what we do know. We know this bit here. So I'm going to do some color coordinating. We need to figure out what part of the equation that is. 12 centimeters is what? This is the rate that the area is increasing as affected by time. So the rate that the area is increasing as affected by time is going to be 12. So dA dt is 12 centimeters per second. So the problem with that is, oh no, that bit's fine. That bit's this bit here. Okay, so let's also look at volume. So I'm going to change colors. So let's look at volume. So the volume of a cube is easy. That's x cubed. So then what I want is the volume with respect to the length, x, right? So the differentiation of this is, whoops, why did I write 2? Is 3x squared. This is the volume as it is affected by the length. This is, remember, we're always finding the derivative is always the rate of change. So it's about the gradient, right? The gradient is about the rate that something is changing. And so that's what we're looking for, the rate that the volume is changing based on the length. So we've got this bit here. So this is going to be 3x squared. We don't have this bit, right? We've got this bit as well. Let me color coordinate that. So this bit is 12. Let's put some green multiplication symbols in. So what we don't have is this bit in here. Let me pick another color. So if I'm trying to figure out the length with respect to the area this time, so how do I put something in there? Okay, how do we find out surface area, right? So surface area, well, that's not a very helpful color. Let's change that color. It looks a bit too similar. Let's do like a medium blue. All right, surface area. Okay, this is surface area that we need to start thinking about. Well, first of all, surface area of a cube, right? Surface area of a cube is, well, x squared, right, is one face, and there are 6 faces, right? So then the area with respect to the length, again, is the derivative of this, which is 12x. Am I being asked for that? No, I am not. I am being asked for the length with respect to the area. So I need to invert this. So this is 1 over 12x. So then I get to put all this together. I have, so this is, well, let's just put it all together. So 3x squared, 1 and 12 is 36x squared, all over 12x. Obviously, that's going to cancel one of that. Divide that out, you get 3. So the answer is 3x. Now, got one last piece of substitution. I want to know when the edge is 10. So it is just 3 times 10, which is 30. And then we need to put in the right units. So this is centimeters. Now, what are we working out? Volume. So it's cubed per second. So this is my final answer. All right, so I know that these are really difficult, but this is an example of doing 3 different things when you've got multiple things going on. This is related to 7, 8, 9. Have a go and good luck.